Okay, so this is that biology problem. Here we go. All students in the class had similar background knowledge of the topic. Some students in the class had no spreadsheet experience, group R, and needed time to learn the program. So I kind of did like learn R. Okay. The rest of the students, group S, had previous spreadsheet experience and they took less time to complete the task. All right, so when you look at it without even going down here, you can kind of see we're comparing group R and group S. If group S has less time to complete it, I'm thinking that this one is group S and this one's probably group R. All right, so A asks, of the two histograms shown, 1 and 2, which is more likely to be the distribution of completion times for students in group R? Remember, it's all about context, right? You have to be able to communicate, use your words. In order to get an E on the EPI scale for grading, they were looking for two things. The first thing was that you correctly identified histogram 2 as group R. All right, so if you did that, then you've got yourself a P for partial credit. But if you want to get the full E on that EPI scale, then you also had to have a nice supporting sentence. It doesn't have to sound exactly like this. Maybe you took a different route, but you had to support it in order to get an E. All right, so here's what I wrote. Students in group S typically took less time, and although the two histograms show the same range, right, when you look at that x-axis, they have the same range. The values in histogram 1 are generally smaller than those in 2, so therefore, histogram 1 is likely group S, and 2 is likely group R. All right, so give yourself an EPI on that one. Hopefully you got your E. All right, for part B, EPI. All right, so to get an E, we had two things that you had to do. If you only did one of these two things, then it's a P. All right. So we want to describe the shape of the histogram created from the data of the two groups of the students combined. I went ahead and combined them. I like to visually see things, so I told the reader to see graph above. If you don't put this in the problem, then they're not going to look at that. If you remember in our days of FRQ practice, they don't grade anything above the questions. This is considered scratch space. So if you want them to consider something you wrote up here, you need to tell them that it's okay to grade it, which is what I did right here. Okay, so the two histograms are combined. So all I did was go through, I'm like, all right, so this first bar had a height of 8. This one had a height of 1, so 8 plus 1 is 9. So on the new one, that height is 9. Then I did the next one, that was 12. This one was 2, so that one had a height of 14. All right, so I just went through and I added up each of those bins to make a combined histogram. All right, when I look at the shape of it, it dips down and back up again. We have two peaks, right? Two humps on this one. So if there's two humps, that's called bimodal. All right, so they were looking for you to name drop bimodal. To get the second point, you either had to have the picture like I have up here or a nice sentence. All right, so if you didn't do the graph picture, then you had to have a sentence to back up your statement about bimodal. The range is still from 35 to 115 minutes, but there would be more completion times in the intervals from 35 to 55 right here and 95 to 115 than in the middle, 65 to 85. All right, so to get the E, bimodal and some support, either a picture or words. If you did both, good for you. All right, down here, consider the population of all students in honors biology classes in the high schools state who are given the task of using the spreadsheet program to investigate the topic in genetics. The distribution of the completion times has a shape similar to the combined histogram. All right, so they're saying the population follows that same trend. Has a mean of 70 minutes and a standard deviation of 26.5. For a random sample of 50 students taken from the population, describe the sampling, sampling distribution of the sample mean completion time. We practice sampling distributions a lot. I hope you remember that day that I had you write on the desk and we had the giant 4 square and we would read the problems and I would yell out, pause! And I would make you decide which side of the graphic organizer are you on. That's exactly what this is. All right, so sampling distribution, there's 4 things you have to address. All right, So since this one is about means, right, they name drop the word mean. I know I'm dealing with the mean symbol. The mean of my sampling distribution, that's this notation right here, is the same as the mean of the population, which is 70 minutes. The mean doesn't change. It's unbiased. The standard deviation, though, we have to adjust it. 26.5 is for the population, and we are taking samples of 50. So we have to apply stats diet to our sampling distribution. So 26.5 divided by the square root of 50. That gives you 3.75 minutes for your sampling distribution. Whenever you are doing adjusted standard deviations, you have to check your 10% condition. We want to assume that there's at least, remember it's 10 times n, so if our sample was 50, so that's 500 students in the population, which I think that's fair to assume, right? We're talking about all the high schools. And then the last thing is shape. Did we have at least 30? Because this is clearly not normal. So to overcome that, we have to have at least 30 by the central limit theorem. And yeah, we're doing samples of size 50. So by the central limit theorem, our sampling distribution is approximately normal. All right, so for grading on this problem, in order to get an E, you had to have these three things. They did not care about the 10% condition. So if you did not do the 10% condition, don't worry. They weren't even looking for it this time. You never know. All right, so you had to have the mean was 70, the standard deviation 3.75. You have to show work. And down here, you had to say approximately normal, right? You don't want to say exactly normal or normal. It has to be approximately normal by that central limit theorem. If you did all 1, 2, 3 of these things, then you've got yourself an E. Oh, there's a 4. All right, so you actually had to show the CLT. Got it. So mean, standard deviation, CLT, and the conclusion that it is approximately normal. So 4 things. Partial credit if you didn't do 2 or 3 of those things. But again, this little box over here, they actually didn't even care about. So if you did it, good for you. Maybe that would push you over the edge if they weren't sure where to put you on your scoring. All right, so look at your EPI for this paper. Score is as follows. Hopefully you were able to get some of that college credit. I'm not sure how they're going to curve things this year. Typically in the past, if you could get 2s on all your free responses, you usually would get the 3 for the college credit. But since there's only 2 free response questions, who knows? Just do the best you can. Remember, it is open notes, so keep everything organized all over your bed or your bedroom, wherever you're taking this test, so that you can quickly access and refresh your memory. All right, y'all. See you later.